Good afternoon. This is Helmi Al-Kindi speaking from Astronomical Solutions Company. Today I've got with me the Ocal World Ocal collimating camera. This is a blessing when it comes to collimating, especially complicated telescopes. So I'd like to demonstrate the product today. There's two versions of this camera. Today we have the Pro camera on display. The main difference is that the Pro camera can be operated via Android mobile phones and hopefully in the near future via iPhones. So let's just get started. The Ocal collimator ships in two versions. We have the Pro version over here, and the main difference is the Pro version has the ability to be controlled via mobile phone. In the box you'll get a USB A to A cable, the Ocal camera with a nice thread-on metal lid. You'll get 1¼ inch nose piece adapter and an adapter that allows you to connect to threaded focusers. I think it's M48 thread size, and an OTG connection. So this has a USB-C connection that goes onto your Android phone. And for convenience, I already connected another unit to the telescope. We'll be working on a Sharpstar D130mm f2.8 HNT Newtonian. This is a telescope that's very sensitive to bad collimation. So this would be a good example of how you would use the Ocal software to collimate this telescope. Now, the first thing you would need to do is go to ocalworld.com/en. If you'd look at my screen over here, that is ocalworld.com/en. You would download the Windows application. They don't have a Mac application, or the mobile phone application. Now, this demonstration we're recording right now is on the PC, but the process is very similar on the mobile phone. And you'll also need to open this Excel sheet, which has the calibration data for your specific camera. Every camera is different. So we have the calibration data over here. What you would do is you would look at the serial number on the side of the box. It's also laser etched onto the back of your camera. And you would look at that serial number and search for it on this column in the Excel sheet. These are the numbers you need. So this is how far it is from the center of the mechanical center of the camera for the position of the sensor. So we would copy these numbers, and after downloading the file, you'll extract all the files onto a folder. So this is the zip file. We downloaded it from their website. You'd extract it, and if you go into the Ocal electronic collimator for PC folder, you would find this text file called focus.txt. So what you would do is those numbers you copied from your serial number, these numbers over here, we would copy these numbers and paste them in the text file. And this tells the software the center of the camera for the specific camera which you have. So then what you would do next is you would open the collimation software. You have two versions. You have the short and the standard. I'll just show you the difference. It's pretty straightforward. So the standard is oriented vertically, and the short version is set up in a box format. That's the only difference between the two. So we turn on the camera, and let me head over to my other camera and demonstrate how this is connected. So we have the Ocal collimator threaded onto the focuser directly with a USB cable headed to the PC. That's really it. That's all you need. Now I have pointed this telescope to a bright window, so I have a clearly illuminated OTA. Now, collimation is simply the process of centering, making all your mirrors perpendicular to each other, or let's just say they're in the correct alignment for the optimal performance of your telescope. So this software, if you notice, I've been turning on these circles over here. This software allows you to see the alignment of the various components and line it up. So we have calibrated the coordinates in that text file. Let's adjust the settings over here. I went to camera settings. I'll minimize these windows in the background so it's clearer and there's less distractions for you. And let's make this window bigger, so you have a better view of what's going on in there. Now the first thing I would like to do will be to enhance the contrast, just so I can more clearly see what's inside there. Okay, you can see here this is the ring of the primary mirror cell in the back. It's a bit washed out, but you should be able to see it. If you look at the, let's try and remove this greenish color. It might be a bit easier to see now. Okay, so this, I think this is clear enough. So the idea behind collimation is to get everything centered. So I have turned on the crosshairs, which is the plus sign in the middle, to help you find the center. Okay, and I have turned on the red circle and the green circle. So the first thing I would like to do is center the green circle on the focuser. So let's increase the size of the green circle. Well, it would appear the software is okay, it's responding now. Okay, so the first thing we need to do is center the green circle on the focuser. Now what I'm doing is I am looking at this circle over here. Let me point that back outside. Okay, so that's my reference. Let me just put my finger back into the OTA so we can make sure we are focusing on the correct part. So yes, this ring over here is the edge of my focuser. So we need to use that as our target. Now, the Ocal collimator has the ability to change the focus point. So let's go back to camera control, focus. Let's focus on that ring so we can see it more clearly. There we are. So we can clearly see, there it is, it's in focus. And apply. So we have focused on that ring. Now the first thing you would need to do is your focuser is the reference. So all the mirrors need to be aligned to the focuser. Sometimes you would set this circle and you'll find that it is not lined up perfectly. If you notice over here on the edge, we're a bit too far to the right. So what you would do is you will do an offset. So my horizontal offset, let me try an offset of 1 pixel. Are we centered? Not yet. So let's go a bit higher on the offset. I think we're perfectly centered on the focuser now. So now we can go back to collimating the secondary mirror. Let's change the camera settings. Let's focus on a different part. Let's focus on the circle of the secondary mirror. You see the secondary mirror is in focus right now. The circle, center spot, it's in focus. Now we can go to the telescope and adjust the screws gently till we get that spot back in the center. Now remember, you don't tighten a screw without losing another one. You have to loosen 2 to tighten 1 screw. And this is to avoid putting too much strain on your mirror. It's almost perfectly centered. I would say we have the crosshairs over here centered on the center mark of the secondary mirror. So the next stage would be to collimate the primary mirror. Now you see these circles we've turned on. We've turned on the blue circle and the red circle and the green circle. So you would use, for example, this blue circle to physically adjust the position of the secondary mirror. Let me just now you'd set this to the size of the secondary mirror. So let's say 550. Maybe 560. It needs to be the correct width. You see this is the edge of the secondary mirror. Now this is used to center the secondary mirror. With this telescope I have no adjustment for the physical position of the secondary mirror, so I would not be using this in this circumstance. But if we want to collimate the primary now, what we'd need to do is move the center of the camera into the center of the crosshair. So what I'm doing now is I'm unlocking the push screws in the back, and I'll be adjusting the pull screws. Seems that this went much easier than I expected. Let's try and zoom in. It is very visible on my screen. but I don't know how good it is on your screen. So let's open the screen magnifier. Okay, there's the magnifier, and you can see, if you look over here, you can see the sensor of the camera is precisely in the center of the secondary mirror, and that's the secondary mirror mark over there. Now that we've zoomed in, we can see that the center mark of the secondary mirror isn't perfectly collimated. So let's adjust that a little bit more. Okay, now that we've adjusted the secondary mirror some more, we need to go back and get that primary back in the center. You can see that the circles are all concentric. Actually, as you adjust one setting, you need to go back and adjust the other one to get perfect correlation. And it appears that our secondary center mark has shifted with the adjustment of the primary. So let's go back and adjust the secondary center mark again. And we're actually very close right now. There, I would be satisfied with that collimation. Now, in order to show you how confident we are with this collimation, let's first exit the Windows magnifier. We don't need this anymore. Let's shift over to a laser collimator for further confirmation. Now, you do have to be aware that these laser collimators themselves need collimation. Unless you have checked them yourself, you can't be 100% sure they're in collimation from the factory. The collimation process isn't actually complicated. You just need to set them up on a V-groove and check when you rotate them that the dot doesn't move around. So let's put this in there and check it out. This telescope requires that you install a special adapter in order to put in 1¼ inch accessories. So let me see if I can focus the center mark in the primary over there. Now I don't know if you can see that, but that's perfectly centered. And if we go to the laser collimator, if I can just get this thing to focus, there you are, it is centered. So as you can see, we have collimated this very accurately. It does need some patience, and there is a learning curve involved. When you operate this camera, you need to understand your telescope, but it gives you two advantages. First of all, it allows you to see that everything is concentric. It allows you to align sideways the position of the mirror if your telescope allows you to do that, because some telescopes do give you that level of collimation control. It allows you to align everything relative to the mechanical position of the focuser, and it allows you to do the collimation in the daytime. I found this to be much more accurate than the laser collimator. And I think with a very complicated to collimate telescope, such as an RC telescope, this camera would be a blessing. I hope you found this video useful, and if you have any questions, don't hesitate to put them in the comments of this video.